Alright, so this is the pressure video. Alright, so the first thing you need to know about pressure, it equals specific weight times height. Oh no, it's fine. It doesn't matter. It don't matter. So the fundamental thing about pressure is pressure goes up when the height goes down because there's more liquid like pushing down, which creates a bigger force on it. So like think of like a little fuck, hold on, let me draw it. Of a little swimming pool. When a person is here in the middle of the pool at like say 5 feet, instead of being at the bottom, which is let me say 10 feet, they're gonna feel like heavier in the 5 feet water than the 10 feet water because it's like more water pushing down on you. So just remember this during like a quiz or something. Pressure goes up when height goes down. It's also important in a manometer and things like that. Yes, Mac. Yeah, I know. So I drew a little random thing with A, B, C, D, E, which has different points of it in water. So point A would have zero pressure because it's at the atmospheric level with the where the water just meets the air. So it's gonna have a zero pressure. Whereas besides B, the pressure is going to equal whatever of the liquid times 5 feet because it's 5 feet deep into the water. While point C equals point D because they're on the same level, making it equal to each other because they're the same height. Because remember, the equation equals density, gravity, height, or specific weight, height. But the deepest one, the one that's gonna have the biggest pressure, is E because it's the low. It has the biggest height away from the atmospheric, which is that little triangle thing right here. And I'd say that's like 8 feet deep. So it's gonna have the most pressure. All right, so right now this is the first manometer problem. I made like the most complex problem possible. So whatever problem y'all have, it's just gonna be easier than this. So the goal for this problem is to find the difference between P1, which is right here in the middle of the water section, from P5. So we're gonna find the change in pressure of that, which is P1 minus P5. And to set it up, you need to do P1 equal, well, not equals, plus the water. And since you're going down, when you're going down in a manometer, it is positive pressure.
Damn, 38. Oh. No, that's when I tried the Popeyes chicken sandwich. $30. But this one has
which relates to this expression right here. When you go down in height, you increase pressure. So when you go up in height, you decrease pressure, which would make it negative. So it will be plus the water portion. So it will be plus whatever specific weight of water, height. It goes down 11 inches, but you use standard notation for this. So you will convert the inches into feet because you can't have the slug inch thing. You have to put in the normal units for whatever that is. So it would be 11 divided by 12 feet.
This is my stupid econ teacher.
All right. So you put in the plus pressure, right? But this little U confuses a lot of people. You just basically use this U from where it stops this liquid and where it goes up into a new liquid. So in this little U, it only goes up 10 inches before it stops into another liquid. And you have to change the pressure and do plus 1 plus P3 plus P4 every single time you enter a new liquid in this manometer. Because once you change into a new liquid, it's a new type of pressure, and you have to find the formula and use another specific weight.
It was so bad. Like
So
when she was doing it, I had her shirt in my hand like
this is S1. So right now I'm about to just put specific weight 1 and solve for it later. But specific weight 1, it goes up 10 inches. So again, you would just use the pressure of 10 divided by 12 feet.
It took long because I kept telling her to stop. Like right when she was about to, I was like, no.
All right. Now that you like transfer to another fluid, which is air, but air in manometers is always 0.
Oh, sorry.
I'm not a teacher. Chill. I'm not a professor either. All right. So air is always 0. So just cancel it off the manometer. Say, just say, we don't want any of it. It's gone. All right. So after you go from air, you have to go from where the air was, where the air stopped, to where the new liquid was. And it goes 6 inches into the center of this liquid. So, oh, see, I messed up. Since this one I went up, this specific weight 1 would be minus since I went up. Well, plus the oil, because the oil goes down, which causes an increase in pressure in the manometer, plus the height, which is 6 divided by 12 feet, which equals P5. So all I would have to do is, to get the P1 minus P5 difference, is just this. Switch that simple algebra, 11, 12 feet minus 1, 10, shit, 12. And don't worry, I'm gonna make another video on this. Right? Oh, my bad. All right. So now that we have the specific weights, we have to solve for them. We're given the specific gravity in these problems. All right. Well, this is one of the most important parts of the video. So most of these manometer problems, you're giving a specific gravity, and you have to use the English or SI unit of water to solve for that specific weight for that liquid. So for this time, I'm an English unit, so I'm gonna use the specific weight of water and times the specific gravity given for the liquid to solve for specific gravity of that liquid. So it would be specific weight equals 1.6 times 62.4, and that equals 1.6 times 62.4, which equals 99.84. And you have to do the other thing for the other liquid, which is S2. But the most important part is, for manometers, just set it up like how I did right here. So it would be easier to just plug and chug over and over, because the most important part is to not mess up the plus and minus signs, or you're gonna fuck up the whole problem and your whole answer is gonna be wrong. And I know y'all don't want a wrong answer, so just focus on, oh dang, it's out of focus. All right, just focus on the up part of the manometer is negative pressure, and the down part is positive pressure. That's just the most important part, because if you understand that, you can solve these pretty easily. All right, so that concludes this video. I'm about to make a part 2 of this, and which one with like a tank or something. And that's it.